Hi everyone. This week we'll be talking about Fermat's last theorem, which was a long-standing open question in mathematics. In fact, it stood for about 350 years before it was resolved by Andrew Wiles in 1995. The proof of Fermat's last theorem is considered to be the greatest achievement in pure mathematics of the 20th century. So what is Fermat's last theorem anyway? Well, it's a theorem or a statement about equations in positive integers. So it says that if n is any integer bigger than 2, then there are no positive integer solutions to the equation x to the n plus y to the n equals z to the n. So it's a fairly easily stated problem, and you would think that it would be relatively easy to solve, but it turned out that that was not the case. Now, the first thing you might be wondering is, well, what happens if n equals 2? If n is equal to 2, then you're looking for integer solutions to x squared plus y squared equals z squared. And it turns out that there are a lot of solutions to that type of equation. For instance, x equaling 3, y equaling 4, and z equaling 5. That's maybe the most famous and easiest solution. In fact, there are infinitely many sort of different solutions to the equation when n is equal to 2. And this has been known for a very long time. In fact, for thousands of years. There's a Babylonian tablet by the name of Plimpton 322, in which we see very, very sophisticated calculations of enormous Pythagorean triples, that is, solutions to the Fermat equation when n is equal to 2. So the Babylonians knew a lot about the Fermat equation when n was equal to 2. So now we move forward to the 1630s and 40s to Pierre Fermat himself, who was by trade a jurist, but by night an amateur, a very talented amateur mathematician. And he was reading Diophantus's Arithmetica, in which Diophantus discusses solutions to integer equations such as the Fermat equation. And in the margin of this book that Fermat owned, he wrote a note saying that one could not split a cube into 2 cubes, could not split a 4th power into 2 4th powers, and that he had a really marvelous proof of this fact, but that the margin was too small to contain it. So this is a very sort of enigmatic and provocative statement on the part of Fermat. Now, Fermat himself was able to prove the impossibility of these solutions in one single case, and that's the case when n equals 4. So he used a method called infinite descent to prove that. And then there were other people, very famous people, who made further progress on the Fermat equation. Like Euler, for instance, showed that there were no solutions when n equals 3. So in the midst of this, this attempt to deal with this Fermat equation, we have the emergence of this really talented, accomplished female mathematician by the name of Sophie Germain, who was a late 18th century, early 19th century female mathematician. And she, among all of these people, was the first person to produce general solutions or general results about the Fermat equation. She was able to show that there are no solutions for infinitely many values of n. Not all values of n, but infinitely many. So this was a real huge step forward. So the Fermat problem became more famous around 1900 with the advent of the Wolfskehl Prize, which awarded, I think it was maybe 100,000 Deutschmarks to someone who would show that that the conjecture that there's no positive integer solutions to the Fermat equation was true. And that prize encouraged a lot of crank solutions. A lot of people who just were very amateur and bad mathematician type people who would try to, produce solutions, and, of course they were all incorrect. So anyway, the problem was famous, but sort of was at the same time sort of dormant until Andrew Wiles, out of the blue, in 1993, announced that he had proved this theorem. Now, Andrew Wiles was not a crank. He's a Princeton mathematician, and when he said that he had proved this, people were listening. In fact, there's a very interesting story about how Andrew Wiles began working on Fermat's last theorem, how he eventually came to a proof in 1993, how eventually there was a problem with that proof, and how it was then corrected in 1995. So it's a very fascinating story. So throughout this week, there will be some videos that you'll see about Fermat's last theorem. And one of those videos was recorded in about 1993, right after Wiles' initial announcement of the proof of Fermat's last theorem. So the proof that Andrew Wiles produced of Fermat's last theorem is not the type of proof that really anyone in a prior age could have produced, because it involved very, very modern mathematical ideas, in particular about elliptic curves and modular forms. So anyway, this story about Fermat's last theorem is a hugely interesting story, culminating in this event of 20th century mathematics. So I hope you enjoy the material this week, and we'll see you later.